Dear friends, today we will derive the expression of electric field intensity due to line charge, ring and charged arc. So these three are very good questions and little small derivations these are. Let's start first. Due to line charge. So this is also your NCERT book question number 30. You can read the question from the book, but in the book it is given to find for infinite line charge. You may ask the question, infinite line charge already you have done using Gauss law, but if you use Gauss law, that only in 3 or 4 lines you are getting the answer. But the question is given without using Gauss law, how will derive electric field intensity due to infinite line charge without using Gauss law, but using Coulomb's law. So using Coulomb's law, we will derive electric field due to infinite line charge, and I am adding one thing more here. Also I will derive today due to finite line charge. Let's do. In NCERT book it is given for infinite, but also I will derive for finite line charge using Coulomb's law, not Gauss law. Okay, let's see. First, line charge. So this is line charge. I am taking one finite length. This is the center O. Suppose I am taking finite length. Let's take the length as L. Okay, this is finite length. I am taking the point just on the perpendicular bisector. Point is P here. Perpendicular bisector. This is a positively charged rod. Okay. At this point we will find which is at a distance R from the center or on the perpendicular bisector of the rod. How I will do this? We will use Coulomb's law, but Coulomb's law is only valid for a point charge. But this is a continuous distribution of charges. Many number of charges are here. How Coulomb's law will be applied? Okay, let's do one thing. Let's divide the line charge into small sections. A small section can be considered as a point charge. We can use Coulomb's law for a small section. Then we will write the expression for the small section. Then integrate it. So this is the overall derivation. Again I am telling you, you just divide the line charge into small sections. You write the expression for a small section because small section is equivalent to a point charge. Then you integrate that electric field expression due to a small section. Now let's see. Now let's proceed here. Consider a small section. Suppose I am considering a small section of width dx, but at a distance x. At a distance x from the center means I now use the variable x here. Okay. At a distance x from the center, in the upward direction, I choose a small section of width dx, and its charge also will be dq, very small charge. Dx small section, charge is also small, dq. Okay, due to this small section, electric field here, where will be the direction of electric field? Towards or away? It is obviously away because it is positive charge. And electric field is also small, for that I wrote here dE. Okay, then what is the expression of this dE? dE is, now we can use which law? Coulomb's law here, because that is considered as a point charge. K dq divided by, then this distance, this to this is r square plus x square root over. But as it is kq by r square, so r square plus x square. So this is distance square, but root over is here, it's square, it becomes r square plus x square. So this is d. This is the electric field due to the small section. Let's work on this electric field. It can be resolved into two components. If this angle is theta, then this angle is theta. Okay, they are opposite angles. This is d cos theta, this is d sin theta. Okay, Now you see d resolved into two components, d cos theta and d sin theta. But d sin theta component will be cancelled. How it will be cancelled? It has no contribution to the net electric field. Why? If we consider another small section just at distance x opposite to it, it will also provide its electric field. This small section also will provide electric field. This electric field, like this you see, now I am showing in dotted line, also provide electric field. This can be resolved into two components. One will be upward and one will be d cos theta in this line. One will be upward d sin theta. So d sin theta component will be cancelled. Okay. So then to the net electric field, only which component contribute? D cos theta. Now let us integrate dE cos theta. Now I hope you understand. Integration is not for dE. Integration is for d cos theta, because d sin theta component is cancelled. It has no contribution to the net electric field. But what about d now? D expression you put k dq by r square plus x square, then cos theta integration. Now we have to integrate this one. Now physics part is over. So now we will do mathematics part, because it is totally integration. Okay. So how to do this integration? Here how many variables are here you see? One is q is variable, one x is variable, one theta is variable. You see q, x, theta. How many variables are here? Q, x, theta. Three variables. How will do the integration? You know only integration of a single variable, but here are three variables. Let's do one thing. Let's convert. In these three variables, let's convert to only one variable. Which variable I choose? Okay, I choose the variable theta. Let's convert q and x to theta. Then integration will be easy. Then you may ask the question, sir, how you know it will convert to theta? Okay, that's by practice. When you will do this practice time and again, then also you will understand this conversion to theta will be little easy. Okay. Now I am doing, let's convert first q to x first. Let's do. How will do q to x? Its linear charge density is given. You can see from the question, lambda is given. Lambda is dq by dx. This one already I have told you about lambda. So now what happened? This dq, now this dq become lambda dx. So now let's put it here. Integration k lambda dx. In place of dq, I put lambda dx by r square plus x square cos theta. Okay. Now q cancel. Now only x and theta. Let's convert x into theta. How will convert x into theta? You see this triangle. In this triangle, tan theta is what? What is tan theta? Tan theta is x by r. Tan theta is x by r. Then what about x? R tan theta. X is r tan theta. So now x converts into theta. R is constant. So no problem. That will not create any problem for us. R is constant. So now x converts into theta. Is it clear? But the problem is again dx is here. So dx, how it is dx? Let's differentiate it. Let's differentiate it once. X differentiation is dx. R tan theta differentiation is what? You must have remembered the expression sec square theta d theta. So this is the differentiation of this one. Is it clear? Now let's put everything there and do the integration. So E integration k lambda, in place of ds r sec square theta d theta into cos theta divided by r square, in place of x r square tan square theta. So is equal to k constant taken to outside, lambda constant taken to outside, r constant taken to outside, within integration sec square theta d theta cos theta divided by, if we take r square common from here, Then what we get in the bracket? 1 plus tan square theta is what? Sec square theta. Okay. Now you see sec square theta cancel. R square come to outside. E is equal to k lambda. 1 R cancel. So integration of cos theta d theta. What is the integration of cos theta d theta? Integration of cos theta you know is sin theta. So this is the electric field expression due to this line charge. But I have not put any limit here. I have to put the limit. Okay, I have not put any limit here. What limit I have put here? You see, if I am considering for a finite rod, then we have to convert that theta is now to our limit. Let's convert the theta into x now. How will convert the theta into x? Let's see. Theta, this is sin theta. From this triangle you see sin theta. Sin theta is x by r square plus x square root over. Now we will put the limits here. Limit is here from the lower to the upper. This total length is L. If this is origin, consider the origin, then this is minus L by 2, this is plus L by 2. Minus L by 2 to plus L by 2. Now you will put the limits. How will you put the limits here? Let's see. How will you put the limits here? So E k lambda by R. Now put the limits. L by 2 divided by R square plus L square by 4 x square. So L square by 4. First put the upper limit root over. Then minus 1 minus sign is here. Minus L by 2. Now I am putting the lower limit minus L by 2. Then R square plus L square by 4 root over. What it is coming? K lambda by R. L by 2 minus L by 2. It becomes L by 2 plus L by 2. So that is L. Then here you take 4 as LCM. It's root over. It will go to off. So it will be 2. Then this will be 4 R square plus L square root over. Is it clear? So this is the expression of electric field due to a finite charged thin rod. But what is given in NCERT book? For infinite rod. If it is infinite rod, then what will happen? If infinite rod, what changes will do? The changes will do here. If it is infinite rod, what changes you do? Let's see. Now you will put the limit. You put the limit in terms of angle. If this rod is infinite like this, here also infinite like this, now you have to put here in terms of angle. If you see here, so this is theta. This angle is theta. But if rod extend up to infinite and this one will now, the maximum value of theta is here up to this much. Maximum value of theta. Now if finite maximum value of theta is this. If finite, then this is the maximum value of theta. But if infinite, then what will happen? This one will go, this one will turn like this to touch the end of the rod, and ultimately this theta will be how much? 90 degree. Again I am repeating, if this is finite, then maximum value of theta will be this much. If it is infinite, then what will happen? So to touch the end of the rod, this now this one will turn like this and theta will be 90 degree. So that side plus 90 and this side also to touch the end it will be minus 90. So limit will be minus 90 to plus 90. K lambda by R. This is sin theta, we have to put the limit sin 90. First upper limit minus sin minus 90. So now it is coming 1 minus. Then this minus come here, so it become 1 plus 1 is 2. So K lambda by R into 2. So this E is coming, how much? In place of K you write the expression 1 by 4 pi epsilon naught lambda by R into 2 lambda by 2 pi epsilon naught r. Have you seen this expression anywhere? Yes, you have seen it in the first application of Gauss law. It was easy there, okay, in the first application of Gauss law. But if you use Coulomb's law, you have to do by integration method. It is little lengthy, but you now got your expression. So this is about a infinite line charge using Coulomb's law. This is your NCERT book, question number 30. You can see the question from the book. Okay. Now we'll go to find electric field using Coulomb's law due to charge ring. If this is a ring now, okay, we will find the electric field at this point, which is at a distance x. Let's say x is constant now here. This is a charged ring, positively charged. I am taking positively charged. You may take negative charge. Doesn't matter. Only direction will change. Okay, expression will be same. So this is Q charge is distributed in a ring of radius capital R. Capital R is the radius of the ring. Again, what we will do? We will use Coulomb's law. To use Coulomb's law, we need point charge, but no point charge here. So we will consider a small section. Now consider a small section. Here you consider a small section dq. Charge dq, small section you consider. Its electric field direction will be where? It is obviously away because it is positive charge. And what is the expression of dE? kq, but in place of q I wrote here dq by this is r square plus x square root over. Here also it will be r square plus x square because this lower term denominator will be in square. Okay, so root over square. So now cancel. Root over now cancel. This is the electric field. Again, this electric field will resolve into two components. Let's see, will resolve into two components. If this angle is theta here, this angle is theta, dE cos theta, this is dE sin theta. It's now clearly visible to you. Which component will cancel? If we consider a small section just opposite to this dq, one electric field will go like this, electric field will go like this. Okay, then can be resolved into two components. One is upward, one is to along d cos theta. To d sin theta component will cancel. So only which component contribute for net electric field? Only dE cos theta. We will do the integration of dE cos theta. Okay, and what is d? dkq r square plus x square cos theta. Okay, then now this expression k constant terms you take outside. R is constant, x is also constant because point P is fixed. Here r square plus x square. What about cos theta? Okay, let's put the expression of cos theta and we'll take the constant for outside. Cos theta is how much? x by r square plus x square root over. That means E is equal to k dqx by r square plus x square, this power 3 by 2. This is 1 power, this is half power, it becomes 3 by 2 power integration k x constant r square plus x square 3 by 2 power constant, only integration of dq. No difficult integration here. It becomes easy. Okay, integration is not difficult here. Only dq integration is what? Only q. dq integration is q. Total charge of the ring. So this is the electric field due to charged ring. And where is the direction of electric field? If the ring is in xy plane, the electric field is along x-axis. If the ring is in yz plane, if the ring is in yz plane, then electric field is along x-axis. Understand? Okay, electric field will be along x-axis. So this is the electric field expression due to charged ring. Let's discuss one special case here. What about the electric field at the center of the ring? This may come as MCQ question. This may come as fill in the blank question. At the center, At the center, what is the value of x? X is equal to 0. Because point P will come to the center. Point P will come to the center, x decrease and become 0. When become 0, what about E value? E value is 0. At the center, electric field is 0. Okay? You remember, at the center of a charge ring, electric field is 0. It's an important line. Okay? Then, at infinite we will put x is infinite. Also, electric field will be 0. Also, we can say at infinite always every field is 0. Not only this ring. At infinite always all fields are 0 at infinite. Okay, but to infinity cannot give its strength. At infinite also E is equal to 0. If you put in the expression this term as infinite, the denominator infinite, it will be 0. Okay, E is 0. So means center 0, infinite 0. Then what happened to this electric field? But here it is finite value. Actually, what happened? Electric field increases, then it becomes maximum at a particular point, then decreases. The question may come, at which point electric field is maximum? Along the perpendicular line passes through the center. At which point electric field is maximum? How will find at which point electric field will be maximum? How will find this one? At center it is 0, but at which point electric field is maximum? Electric field maximum, I have told you one concept. A quantity will be maximum if its derivative is 0. This is a concept, remember. Okay, its derivative is 0. If derivative 0 means dE by dx. Now x will be variable because we are changing x. So d by dx is equal to 0. We have to do the differentiation of this. You will do the differentiation. I am not proceeding. Okay, and at last what answer you will get? R by root 2. You must get R by root 2, and 1 by root 2 value is 0.707 into R. You remember 1 by root 2, 0.707. Many times in physics it will be required. Okay, so at this point electric field will be maximum. If I draw the graph of electric field, now you see this is the center of the ring. And electric field increase, then decrease, become 0 up to infinite. Here it is electric field R by root 2. Here it is maximum. This is electric field and this is X. And to this side also same thing happens. Increase, then here at X is equal to minus R by 2. If it is ring, it is symmetric to left and to also right side. This is the expression of electric field versus distance from the center of the ring. I hope now you could able to understand what happens to the electric field of ring. Let's go to the third question. Electric field due to arc. What happens to the electric field due to arc? Let's consider this is one arc. Now this is a charged arc. This is positively charged. Okay, so we'll find the electric field at the center of the arc. How will you find the electric field's radius is R. Radius of the arc is R. Okay, we'll find the electric field here. Linear charge density is lambda. This is given. How will find it? We'll use again Coulomb's law. To use Coulomb's law, we need point charge. Point charge means here small section. Now let's consider a small section here. Let's consider. And at how much angle? At angle theta. At angle theta. Now I am taking the variable as theta. Okay. Now you recognize your variable. The variable is theta. At angle theta, I consider a small section which make how much angle? D theta. D theta, central angle D theta. At angle theta, at center, taking center angle D theta, I consider a small section. Its charge is dq and also its width is dl. Take its width as dl and charge as dq. So it's positive. Electric field direction will be here d. Electric field direction is d. D can be resolved into two components. One is here, one is here. So this d, if this angle is theta, then just its opposite angle is theta. So this is d sin theta and this is d cos theta. Is it clear? Now integration. Now which component will cancel? Now see, if we consider a similar section just opposite to it here, so it will provide again the one component downward, one component to this side. So it's clearly visible d cos theta component will cancel. Which component will remain? D sin theta component will remain. So now I am showing, if you can understand, the electric field will be like this. Provide one component downward, one component to right side. Then d cos theta component will cancel. So our integration only to which component? dE sin theta component. Integration K, what is the electric field? dq by, this is r square because the distance is here r. Okay, so d expression K dq by r square into sin theta. What are the constants? K by r square constant, r is radius always constant. Integration dq is variable and sin theta is variable. What to do here? I have told you two variables, not possible integration. We'll convert one variable in form of other. Let's convert in form of theta. Let's convert dq in form of theta. How will convert dq in terms of theta? K by r square. Similarly, you know lambda is dq by dl here. I have taken dl small section. So lambda is dq by dl. So dq is lambda dl into theta. Okay, since this is equal to k by r square, now lambda is taken to outside, but dl is the variable. How it says dl? You use the sector formula here. D theta is central angle. Theta is equal to L by R. You know this expression lower classes. Theta is L by R in a sector. I put it. So dl is R into d theta sin theta. Okay. So now k lambda by r square. Then again r come to outside. Integration of sin theta d theta, and this become k lambda by r. What is the integration of sin theta? It's now minus cos theta. But I have not put the limits. Now I have to put the limit. What limit I put? When I take the small section here, what will the value of theta? 0. Then I will choose the small section like this, like this, like this. Then I will come to here. When we will here, then this theta will increase like this, and will become 180. Theta is measured always with the positive axis. Okay. When I consider the small section here, theta is 0. When I consider the small section like this, then come to this limit, then this theta will increase like this, then become 180. So limit is from 0 to 180. Now put the limits E k lambda by r. Put the limits now. Minus cos 180. Then minus it become plus cos 0. K lambda by r. This is minus 1. It become 1 plus 1. So now 2. In place of k you put 1 by 4 pi epsilon naught 2 lambda by r. So you are getting lambda by 2 pi epsilon naught r. So this expression is the expression of electric field due to an arc, charged arc. This is the expression of electric field. It is exactly similar to the electric field due to infinite line charge. And where is the direction of electric field? You mark, if this is the arc, resultant electric field is along d sin theta, means in this direction. If this is the arc, then electric field resultant will be in this direction. If it is positive charge, but if the charge is negative charge, then resultant electric field will be in this direction. Sometimes this direction only also asks in MCQ questions. So today I discussed the electric field due to infinite line charge, also due to ring, and due to charged arc. I hope you will practice it time and again, then you will be clear. And with this, the first chapter of NCERT book is now complete. From the next lecture, I will start from the second chapter of NCERT book, that is electric potential.